time. Okay. So, we're ready? Let's do it. So, I guess, first of all, I'm going to have to get used to this, but I am just going to give you a ton of examples to teach all these new topics that I'm about to teach to you. You're, of course, not required to memorize them. I want you to get a feeling for everything that I'm doing, so that eventually you can do it yourself. No memorization involved. Just understand the concepts. They're all examples of computational thinking, so don't get too confused or too scared, like I'm going to have to do this myself eventually. You are, but I'll get you there slowly, all right? All of the stuff that I'm showing you in class is to prepare you for all the stuff I'm going to ask you to do, to complete your labs, your Xylabs, even to understand your book. And a nice thing about my classes is that I let you cheat during your tests, as long as you don't talk to another human. It's all open book, open notes. When you're a programmer in real life, you get to use Stack Overflow all the time, so mine as well. All right, so let's talk about branches. I guess before we get there, how are we enjoying Nano and Vim? Are we all learning Vim slowly? Because it's so much better than Nano. Please, I will help you if you have any issues with it. You can also use Emacs. I don't know if I have that installed in the server. If you would like to try that out, it is a competitor to Vim, and I can totally install it on the server if you're interested in learning it. Also, if you'd like to get a terminal on your own machine, so you could compile and run your own programs without connecting to the server, I can help you with that. And then you can use a graphical editor called Visual Studio Code. That's what everybody likes these days as well. Okay, so just try to learn Vim if you can. It'll make your life so much easier on the server, and it makes you look cool as well. Okay. Before we get into branches, there is a nice feature of the terminal that if you are confused about how a certain terminal command works, you can look it up in the manual. You can say man, that's a terminal command itself, manual, give me the manual page for ls, man ls. And you can scroll around with the arrow keys or the Vim key bindings. And you can press Q if you're done looking at it. It's like ls, list directory contents. Take some options, take some files as well. ls-a, ooh, okay. Do not ignore entries starting with a dot. ls-a. Ooh, there are secret things here. ls, my home folder. ls-a, my home folder. Ooh, there's a lot of stuff there that's hidden normally. So, yeah, look into things. You can also say, like, man G++. How do I use G++ better? What are all the different cool commands I can give? There's a million. Different options. You can also say man. Tell me more about the manual, please. There's different little sections of the manual. There's a lot going on there, but look into it if you're interested. It's very helpful. So look things up in the manual. That's built in. All right, I think we're ready now. So let's talk about how to make decisions to ask questions in a program, because it would be nice. It would be nice to have options when we are making our program. So to be able to do one thing or another, because right now our code looks like this, right? It's like I say line A, I say semicolon, line B, semicolon, line C, semicolon. And the way this program executes, the way that all of our programs are executing right now is, all right, first do A, then do B, then do C, in that order, and that is the program. Okay? That's a little boring. Wouldn't it be nice to be able to branch off? That's why it's called branches, and do one thing or another thing. For example, we have no way right now of printing even or odd to the user. Like, we ask them for a number, and then we can't print, oh, that number was even or it was odd. We have no way of doing that right now, okay? Depending on the number that they give us. So we'd like to be able to do something like this. Get a number like into a variable called x, check, ask the question, is x even? And then depending on the answer, do one thing or another thing. If it's yes, print even. If it's no, print odd. Like, our programs are branching off, doing one thing or another. We cannot do that right now. And then maybe you can just come back after you're done and do more straight line code down here. That's fine. You can kind of cheat and get close to this program, right? You can use your modulus operator. You can say like int x, get into x from cn, and then you can output maybe x mod 2. That would work. It will print 0 if it's even, because the remainder is 0, and 1 if it's odd. But again, it's not printing the actual cool looking strings, just like a numeric code for evenness or oddness. So we'd like to be able to make it pretty. Okay, so that's where we're going. And it's called a branch because it's like the branches of a tree. Like the program might go this way, or it might go this way. One of the two. Any questions about that idea? That's something we can't do yet. And we're going to be able to do by the end of this class. All right, so here's my silly example from Mean Girls. We're going to make a program that asks the user what day it is, and if it's Wednesday, we will say that you should wear pink, because that is something from the movie. Maybe I need to change this because this isn't in our cultural repertoire anymore, but that's okay. I am culturing you. All right, so here is what you do with code if you want to do one thing or another. It's called an if-else statement, okay? It lets you branch off and do one thing or another based on the result of what's called a Boolean expression, okay? A Boolean expression is just a fancy word for some code that either becomes true or false, okay? True and false are going to be our friends for this class, okay? So we're going to eventually be able to ask this question. Is today Wednesday? Question mark. And then, depending on the answer, we'll do one thing or another. But instead of yes and no, like do something if the answer is yes, do something if the answer is no, in computer science, we're like, nah, we're going to call yes true. If the answer is true, today is Wednesday. Instead of no, we're going to say false. If the answer is false, then today wasn't Wednesday. Okay? So we're going to replace yes with true and no with false, and that's going to be our life for the rest of our computer science career. Okay? Then we'll do one thing or another based on that. And here's what the code looks like. It's weird looking. So you say if, and then you put some parentheses. And inside of those parentheses, you put something that becomes true or false. I'll show you how to write some code that does that. And then you put some squiggly braces. And then in between the squiggly braces the first time is what you want to have happen if the Boolean expression is true. And then you can close it off and say else, some more squiggly braces. And inside of those that second set of squiggly braces, you can write the code that you would like to have executed when the expression was false. So it's either going to, after checking this, jump here, run this code, or jump here, run this code. And then the whole thing's done, and it can go and work with the rest of the code down here. Okay, so that's a if-else statement, and I'm going to give you an example of it. But the first thing we need to get at is, what do we put in here? What's a Boolean expression? How can we make something that becomes true or false? So let me teach you some easy ones. They're called relational operators, okay? They are the double equals, the exclamation point equals, you got your less than, greater than. In C++, it's very hard to type this character, right? It's like a Unicode character. So instead of less than or equal to like this, we just type it a less than and then an equals to sign. So this stands for less than or equal to. This stands for greater than or equal to. And these are checks. We're asking the computer to check for us. Is the result yes or no? So you can ask, hey, is 2 equal to 2 C++? And it gives back true. Of course they are. You can ask, hey, is 4 not equal to 7? And it says yes. The answer is yes, so it's true. That's a true statement. 4 is not equal to 7. You read this as not equal to. Okay? Is 2 less than 3? Yeah, true. Is 2 greater than 3? No, false. Is 2 less than or equal to 2? True. Of course it is. 2 is exactly equal to it. Is 3 greater than or equal to negative 42? Of course, still true. Is 3 greater than or equal to 5? No, false. So those are questions you can ask of C++, and it will compute them for you. And you can put those in your Boolean expression slot of your if-else. So you can be like, if 2 is equal to 2, then do one thing, else do another thing. And of course, we'll never get to this else. It'll always run the if part because it's true. And it's always true. It never changes. Okay? Any questions about this idea? What a relational operator is? because that is going to start us off. What do I want to call this? That works. Are we good to move on to write our silly little program? Alright, so here is our game plan. I'll just draw it again. What we'd like to do is ask the user, like, what is today? Please enter the day, something like that. And then we'll check, is the input that we got equal to Wednesday? If so, if it's true, we'll say you should wear pink. Otherwise, we will say you should not wear pink. And after that, we're done. Okay? You can come back to straight line, come back to that. So, without any further ado, let's do this. So, Vim, what do I want to call this? What did I call it last time? I just call it ifelse.cbp. So, I'm going to get a string from the user, a word, so I'm going to include the string library. And string today. And let's ask the user to fill that in for us. Cout, enter what day it is, colon space, get it into the today variable, and then we're going to do one thing or another based on whether or not today is Wednesday. So if today is equal to Wednesday, then we're going to see out, well, you should wear pink or something. Yeah, wear pink. Okay. Otherwise, else, see out, don't wear pink. One or the other. That's it. Does that make sense? And then after it's done one or the other, it just goes to the rest of the code down here. Like the whole if else is now executed. It can do more stuff down here. More straight line code can go here. I can see out done, whatever you want to say. You can do fancier stuff. But that is the program, and let's run it. Now let's save it. Get up here. There. Enter what day it is. Well, currently it's Thursday, right? So hit enter. It put Thursday into the today variable. Compared it with Wednesday. The answer was false, of course. Thursday is not equal to Wednesday. So is Thursday equal to Wednesday? The answer is no. So it's false. It hits the else case, and it runs that code, and then it's done, right? Don't wear pink. Otherwise, if we pretend that today is Wednesday, it goes and it hits the true case. Like, yeah, wear pink, because this answer is true. Today, which is Wednesday, is equal to Wednesday. Cool, wear pink. So it does one thing or the other thing, depending on this Boolean expression. Isn't that neat? Are there any questions about that? So yeah, new syntax. Remember your little curly braces. It's if some Boolean expression within parentheses, then else. Else means kind of like otherwise. Otherwise, do this other thing. Okay. So that's that one. Let's do our even odd program now. Hey, I'm going to show you some terms after I do it, but let's write our even odd program. So we're going to get a number from the user this time. Get input. And then we're going to check, is the input even or odd? What's that condition we're going to check? We'll do that in a second. And then if it's true, maybe we'll check for evenness. And so if it's true, we'll print that it's even. Otherwise, if it's false, we'll print that it's odd. And here is one way to check for evenness. We want it to be true if it's even, let's say. So to check a number, if it's even, like 42, you divide it by 2, right? And you check the remainder. So like this is supposed to be 21. Remainder is 0. So if the remainder is 0 after dividing by 2, it's an even number, right? You do it with 43, then you get 21 remainder 1, right? So even. It's like that. So we're going to check. We're going to do the number. Let's call it input, I guess. We're going to divide it by 0, or divide it by 2 and get the remainder. That's mod 2. And then we want to know which one was it. We want to check if it's even. We want this to be true if it's even. So we're going to make sure, check, and see if it was equal to 0. equal 0. Okay, so if the input mod 2 is equal to 0, that means this remainder was 0. If it's saying yes, it's true, that means it was an even number. Otherwise, it was an odd number. Any questions about why this is the proper condition? Check if the result of dividing by 2 and getting the remainder is equal to 0. Check that there is nothing left over. That means the 2 went in cleanly. All right, let's code it. Even odd.cpp. So int n, enter number, cnn, and then if n mod 2 is equal to 0, then this is the even case. Otherwise, this is the odd case. So we can print those things. Cout even, cout odd. Okay. And then if we had more code down here, it would do that more code. But it's just going to stop the program, return 0. Enter a number, 42. It's even, because it does 42 mod 2. That answer is 0. It's checking, hey, is 0 equal to 0? Yes, it is. True case, even. Otherwise, if this is false, like it would be if I type 43, it's going to check, hey, n mod 2, 43 mod 2, that's 1 left over. Is 1 equal to 0? No, false. So it goes and it hits the else case of the if-else statement. Okay? And it runs the code there. And it prints odd. Are we good with that? It's checking one thing or another thing. So let me teach you some terms now. This thing between parentheses, this question that you're asking, is called a condition. Well, let's do this in green, I guess. This part right here, that is your condition of your if-else statement. And then you have the true case and the false case. In between the little squiggles, we call this the body of the if, the body of the else. It's a weird little metaphor. It's like, I don't know, like the condition is the head or something. Like this is the main part. We call it the body. Body of the if part. Body of the if. And this one down here, these two lines are the body of the else, the stuff between the squiggles. So you'll hear me say that a lot. It's just the stuff between all that code that you want to have executed in the else case. I call that the body. That's the technical term. So those are just new terms, but that was our program that we now know how to do. We now can make a thing. Are you good with that? All right, let's keep on trucking then. So the next thing that I want to say is you don't need to have an else. The if can exist on its own if you do not need the else. And what will happen then is it will check the condition. If it's true, it will run the body of just the if, and then you don't have a corresponding else. If it's false, it'll just skip this whole thing and do nothing, and then go straight to the rest of the code. But if it's true, it'll run the body and then go to the rest of the code. That's all. So that's better than just saying something like else empty body. That's kind of silly. We don't need to do that anymore. We can just say if by itself. Okay? Alright, so that's if and if else. I have a very weird thing to show you if we're ready for it. Is this what I want to show you? Yeah. Oh gosh. This is a very silly thing, but it is useful. In a very weird way it is. I promise useful. But it will bite you more often than it is useful, I think. At least right now. So there is a concept of truthy and falsy numbers. Weirdly enough. So C++, it implicitly converts things, including numbers, to true and false if they need to be evaluated to true or false, if they're part of a condition, for example. This is something you should never really do right now until you get more experience, but you can say this. You can say if 42, do something. C++ will implicitly convert that to either true or false. And I have to tell you which one now. So here it is. Every number in C++ other than 0 is true. It will make it true and pretend that it's true. Otherwise, 0 is false. That's the one time it's false. So legitimately, if you say if 42 do something, it will run that something because that's true. ... That will actually work. It will run this code for sure. This is true. Crazy. If you say if 0, it will not run that thing. Maybe if you had an else, it would run the else. Because that's always false. It's going to pick this one. False. Crazy. So yeah, every number other than 0 is true. 0 itself is false. Please never do this. Be like, if you need to check for zeroness, just check, hey, is your number equal to 0? Just check something like that. That's not going to bite you. Now at least you know what you're checking, right? Otherwise, it's a bit silly. But once we talk about pointers, much later in the class, this syntax is useful to us. Any questions about that? So yeah, if you ever try to make a condition the result of an arithmetic operation, as long as it's not 0, it's true. Okay? Are you ready for a question now to try yourself? All right, here's my question for you. Please get into your little peer instruction group, say hi to each other, and we'll do a by-clicker question. Yeah, it is a by-clicker question, so please go there. And I'll let you have time to do that. Look at this code. Try to run it in your mind. I would prefer it if you did it that way. What does the following code print? All this stuff. Okay? Does it print it was 42 or does it print it was not 42? That's my question for you. So please help each other. It's really, really good to get good at doing it in your mind if you can. Execute code in your brain. I'll give you, 2 minutes? Yeah. So you think it's around the 42, okay. Surely this answer is very simple, isn't it? If you have extra time, you can code it up. See if it matched your intuition. Definitely try it in your mind first. Take another minute or so, and then we'll talk about it. All right, that was my timer. Did we all get our answers in? Put something in there, and also yell at me right now if you did not sign in for attendance, because I want to stop that too. Speak now or get marked absent. Okay. We'll wait until the end of the question then. All right. Give me till 3:10. And then I'll stop the bi-clicker question. Boop. Look at us. We're saying it was not 42 because it's 41, right? That would make sense. So let's check our intuition here. Dun, dun, dun. What do I want to call this? 42.cpp. Let's make it pretty. Oh, and copying from PowerPoint. PowerPoint likes to use fancy quotes. C++ does not understand fancy quotes. Dun, 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 dun. Pay no mind to that little warning sign. Files. So we were thinking B prints it was not 42 because X is 41, right? Trick question. So it prints it was 42. What? But it's 41. Excuse you. Does anybody see the error? It's being underlined right now. What's wrong? Yeah, that's not checking for equality. Checking for equality is 2 equal signs. 2 equal signs. Checks for equality. What does 1 equal sign do? It sets a value. It's an assignment operator. That's why we couldn't have that one. We needed 2 equal signs to differentiate from that. If I forgot it, what is it? It's, So the answer is A. Let's talk about why. So double equals checks for equality. Single equals is assignment, right? That's one thing we need to keep in our minds now that we have both options. Second thing causing this issue is you are allowed to put whatever code you want inside of the condition. But a single number, you can put an assignment statement. Why not? They let you do that. You can put random code in a condition, including an assignment statement. And the issue is the result of an assignment statement is the right-hand side of the assignment. So, okay. What's going on? So X was 41, right? C++ was running if X is equal to 42 as an assignment statement. It needs to check this, so it needs to run the code. It's legitimately setting X to 42. And then the result of this assignment statement, because it needs to be like, hey, is this whole thing true or is this whole thing false? The result of an assignment statement in C++ is the right-hand side. So it's essentially doing the assignment and then checking if 42 is true, which is true. It's a truthy number, if true. And so not only does it set it to 42, it will also run the if body. Does that make sense? Will we watch out for this now? This is definitely going to bite us in our code as we start out. It happens every semester, but at least now you've seen the problem. Just check for it. If something is weird in your code, something weird is happening, it might be this. Okay? So it's setting X to 42. The result is 42, which is a truthy number. So it's going to print it was 42. Alternatively, if X is equal to 0, now it gets extra weird. Because not only would it set X to 0, and it would be equal to 0, but this is a falsy number, so it would then hit the else case. That's weird. Weird quirk of C++. So, all right, why wasn't this an error, you might be asking? Well, because every statement, even an assignment statement, has a value. It ends up giving it back if you need it for your purposes. Like, this is one of those times. And probably the only thing that you can gain right now from this issue is this. You'll see me do this in code sometimes. You can have multiple variables, just declare them, and you can initialize them all at once to the same value because of this error. You can write a line that looks like this. X equals y equals 42. And that will set both x and y to 42 because it'll draw the parentheses this way. It'll be like x equals y equals 42. And so it'll run this first, set y to 42, and then the result of that is 42. And so then it'll set x to 42 as well. So you can set as many variables as you want on one line with the syntax because of this problem. Okay? It's a feature. That's why the assignment statement gives something back. Okay? So, yeah, just watch your single equals versus double equals. Now you know. Any questions on that before I move on? That's just pretty disgusting, though. At least to us right now. But now you know. Let's see. What do I want to do next? Do I want to code that? Let me check. I don't think I do. Okay, so next thing. You can put whatever you want inside of the body of an if statement. That includes more if statements. You can put ifs inside of ifs. So this code can do some cool stuff. At the outer edge, you check first, hey, is x even? Right? That's the very first thing that plops you into the body of that outer if, right? So the first thing in this statement, what it's doing is it's checking, hey, is x even? Is x even? Question mark. If it's false, it does number 3, the rest, right? Go straight here, x was odd. So I'll call that like the rest of the code if it's false. Rest ... But if it was true, it goes inside the body and it runs another if-else statement, right? So the first thing it checks is its condition. Hey, is x positive? X pause, question mark. And then if that's true, it'll run the body of the first, or the body of the inner if. So it'll run number 1 and do stuff. Otherwise, it'll run case number 2. It'll run the else and do stuff. And then this whole thing's done, which means the body of this if is done, which means we can move on. Okay? So we go down to rest after all that. And you can ask yourself, in these bodies, what is true? If I hit here, what's true? If we go straight here, that means x was not even. We didn't hit the if at all. So x was odd if we got to 3 first, right? So that means x was odd if we took that path. Otherwise, if we're in here, we know, if we're in here anywhere, we know that x is even, right? Because that had to have been true for us to hit the body of the if. If we're in here, we know that x is both even and positive, don't we? That's quite nice. You can check multiple things, even and positive, e comma plus. Otherwise, we're both even and negative if we hit the else case of that inner if else. We are even still, but we're negative now. Okay? So you can check multiple conditions, ifs inside of ifs. Totally fine. It's just code at the end of the day. Does that make sense? Question?
So, is there and statements as well, or is there ifs or yes and statements?
This technically does the equivalent of an and, but there is also an and I will teach it to you. Yeah, you're getting ahead. I like it. We will be going there soon. Any other questions? All right. So, yeah, let me show you some fanciness, okay? Because a very common pattern in C++ in programming is to try alternatives. Like do something if today is Monday. Do something if today is Tuesday. Do something if today is Wednesday. So here is my example. Let's do Monday, Tuesday. Let's make it smaller. Let's abbreviate our days. So if today is Monday, let's change Monday to Mon. If today is Tuesday, let's change Tuesday to 2. Something like that, okay? So this is the program I'd like to write for us right now. We're going to take a word from the user that is a day, and we're going to shorten it. We're going to convert Monday to Mon, for example, and every other day as well. So, yeah. This is possible right now with our nested if-elses. We have to do something like this, right? There's two ways to do it. I'm going to show you the hard way first, and then I'll show you some cool new syntax that involves else right next to an if. So you start off, you're like, hey, is the day equal to Monday? Because you need to know, like, what was the day? Was it Monday? Was it Tuesday? Was it Wednesday? Because you have a different abbreviation per day, right? So was day Monday? Monday. That was all horrible. Sorry. Let me rewrite all that. Monday. If that's true, I want to see out mon, right? That's the shortened form. If that's false, well then, the day wasn't Monday. Maybe it's Tuesday. Maybe it's Wednesday. Maybe it's Thursday. I need to try the other alternates now, right? So then check, was the day equal to Tuesday? If that's true, the answer is 2, right? That's the abbreviated form of that day. But if that's false, that means the day wasn't Monday, nor was it Tuesday, so I better check for Wednesday, Thursday, Friday, all that other stuff. So then we'll check next. Hey, is the day equal to Wednesday? Yeah? If that's true, we'll print wed. Otherwise, we gotta try other days, right? Those are all the options. We have to try every option. Okay, so that can be translated into code in this way. That's gonna get a little ugly, but that's okay. I'll just do the weekdays. Let's just do Monday through Friday, because otherwise it's gonna get silly. Let's call this else if.cpp, because I'm gonna show you else if in a second. Okay, so main. Let's do this. Let's get the current day, string day, see out, enter the current day, or enter a day, whatever you want to abbreviate, cn into the day, and now I want to do this. Like if the day is Monday, print mon, if the day is Tuesday, print 2. Let's make it happen. So if day is equal to Monday, see out mon, else. So now we know it wasn't Monday, but it could be any other day. Was it Tuesday? Wednesday? Question mark? So I gotta check all of those inside of the else, right? So next option, if day is Tuesday, well in that case we'll print 2, right? Otherwise, if we get here, it wasn't Monday or Tuesday. See that? It's just kind of like indenting itself as we go further inside if the answer keeps being no. So now if it wasn't Monday or Tuesday, maybe it's Wednesday. If day is equal to Wednesday, then we are going to see out wed. And I should be adding new lines everywhere. Let's fix that right now. Oops. Up. New line. New line. Before I forget. Otherwise, it wasn't Monday, Tuesday, or Wednesday. If day is equal to Thursday, then see out the new line. And then let's just assume it was the weekdays. Oh, forgot double equals. Let's assume it was the weekday. So if it wasn't Thursday, must have been Friday. See out Friday. Assume the last option is Friday. Okay, must have been. Okay, so that's just disgusting. See how the more options you have, the farther to the right you have to indent. Like, all right, it wasn't Monday. Try this whole thing. That's what happens if it's not Monday. Then, okay, is it Tuesday? Then we'll print this one. Otherwise, this is what you do if it's not Tuesday. And it also wasn't Monday, right? You see how it's moving on in like that? That's one way to do this correctly. It's totally fine. It's going to work. Boop. Enter day Monday. So it prints mon and then like it skips the rest. It does the if statement's body. It skips out on the else because it was true. Let's do Tuesday. And it only prints 2 because it wasn't Monday. It hits the else, and then it tries this entire thing, this big if else. It's like, is it Tuesday? Yes. Okay, so we run this body, skip out on the else, that big one. And so on and so forth with the other days, like Thursday. So it goes all the way into here. And I encourage you to look at this code after class and understand why it's getting here and it's only printing the. Friday, fry. Okay? Must have been Friday in that case if we got all the way into here. Okay, so that's one way to do it, but it's kind of ugly because you got to indent. It just looks weird. A lot of if-else's. There's a way to do this better, okay, because of this pattern. And it involves being able to say the word otherwise in C++. Otherwise is else if. You put them right next to each other. That's essentially the word otherwise as far as C++ is concerned. So that's going to allow us to do something like this. So if, try option 1, do option 1. Else if, you read that as otherwise. Else if this other thing is true, try that one instead. Else if this third option is true, try that one. And then you can have as many of those as you need. And then finally there's an else. Else. I tried. Oh, I love PowerPoint, and that's a lovely bug. There we go. Else. Then you can do the final option if none of those were true. So this allows you to not have to indent. You just say else if, and that's your next option that you want to try. Okay. And it will perform the same stuff. It'll be equivalent to this idea still. It just is. It looks a bit cleaner, and everybody prefers it this way. So it's called else if. And so here's how you translate all this to using else ifs. I'm going to copy and paste it, because why not? And I'll show you how it works. So instead of saying else and then checking Tuesday, you just say else if it was Tuesday. Else if day is Tuesday. Do this one. Else if day is Wednesday. Do this other one. Else if day is Thursday. Do this other one. Just read that as otherwise. And then else was none of those, but it would have been Friday. And then I don't need all these extra braces. It's just much cleaner. So read else if as otherwise. Again, it's only going to do one of these bodies, but which would you prefer to write? This monstrosity or this one? It does the same thing. It's like, if today's Monday, print Mon, we're done with the whole if, else, whatever. Otherwise, if it wasn't Monday, let's try this option next. If it's Tuesday, we'll print 2, be done with it. Otherwise, if that wasn't true, we'll see if it's Wednesday. Print Wednesday and be done with it. If so, on until we get to Friday. Okay? Only one option is going to hit and be executed. So no matter what, it's going to print the same thing twice because it's equivalent code. Fry. Okay? Any questions about this? You can essentially treat it as a new piece of syntax, but this is a very, very nice pattern, and it's going to come up a lot in programming. Are we happy with that? So it kind of looks as you would want to write out a plan for the program in English. Okay. Let's see here. I want you to share this code. You can just work on this together. We can try it at the end of it. So here's a question for you now. So write some code. You don't have to write complete code. Just assume you got a double variable and it's called grade. Print a little grade calculator, please. So print C if the grade's between 70 and like 89.99999 on forever. There's a way to check that with just checking grade is greater than or equal to 70. Think of how you might do that. Say that the grade is an F if it's less than 70, and that can be your condition. And that the grade was an A if the grade was greater than or equal to 90. And it's like, if you do it right, it'll be a C if it's not greater than 90, but greater than or equal to 70. There's a way to arrange those things. And I guess I do want your answer. So let's go to the written nice page. Why not? Somebody open up Notepad in your group and type up the answer. Okay. Are we done with attendance, by the way? Can I stop that now? Yes? Thank you. One last tab for me. So go to the written nice page. Let me clear it out for us. Figure out where your group is. And paste some code that you write in, if you can. Assume that you've got a grade that's a double called grade. and then use grade to write an if statement, if else kind of statement, to see what grade it is. So like if grade was 70 or less than 70, you print F. If it was between, you print C. Otherwise, you print A. Okay, does that program make sense? It's like you're using the grade variable to output a grade. It's just a simplified grade if there's only A, C, and F. And you can definitely make it work with just these conditions. You might have to reorder them, though. Wink, wink. Okay? Any questions about the question? All right. So we got plenty of time. So take like, I don't know, take like 3 or 4 minutes. Give this a try and paste something in. I'll give you 4 minutes. Yes. You could just write the if part if you'd like. You can assume you already have the grade variable. But if you'd like to write the full code, I won't stop you. Help each other. Oh, no, I think we're done. I think it's the EMB. Great. Take another minute to get your best answer in. Did you figure out the correct rearrangement of the conditions? I didn't arrange it. I didn't arrange it. This one, I need to be put since I arranged it. Right. what we've got so far, and then I'll code it up as well. But what was the proper order? Like, which condition should we check first? Let's see what we're thinking. Yeah, so I like group 4's answer, because A should, as long as, assuming you're using these conditions, I think, technically I think you could check for F first if you wanted to, but the check for A should come before the check for C, because it's more, or it's less, what's the word? It's more specific. It's a smaller range of numbers that work for A's rather than for C's. And I'll show you what I mean in a second. Yeah, looks like we're getting it. Nice. So 90, check for A, then C, then F. That's the standard way of doing it. Beautiful. Ooh, nice and very formatted. Beautiful. All right, so that is correct. Why can't you have check for C first? Can anybody explain that? It'll always say C because that's the first thing that's being checked. Good. Let me try it that way first. So double grade, C out, enter A grade as a percentage, CN grade. Then if, what was it? Grade is greater than or equal to 70.0, let's say. Then C out C. Else, if grade is greater than or equal to 90.0, C out A. And then you could honestly get away with just saying else right now. Otherwise, C out F. And I'll show you why in just a little bit. You actually need to check for less than 70 if you do it in the right order. Whee. Okay. So let's run this. I believe it will work for C's and F's right now. I'll try and walk you through why. So enter grade 75. That's a C. Enter grade 55. That's an F. That works out. If I enter grade 95, though, it still says C, because the very first thing that's being checked is, hey, is the grade greater than or equal to 70? 95 sure is greater than 70, so it's printing C. And it's like, I'm done now. Does everyone see the problem? If we didn't see it before. So we need to do the more specific thing first. The harder to make true case needs to happen at the top. Kind of got to go in order. So this better be the check for A first. C next. All right? Because look at what's going to happen now. Let me show you that this works. First of all, 95 is A, 75 is a C, 55 is an F. Beautiful. And the reason it works is because anything greater than or equal to 90, we check that first, like 95, 90, that's an A. Otherwise, if that's not true, if we hit either of these, the second that's false, we know that the grade is strictly less than 90. It's 89.999999 downwards, right? Because this was not true. The only way for it to not be true is for it to have been strictly less than 90, all right? And that's why you can get away with checking for a C with this one next, because you know that if you ever made it to these checks, it was less than 90, right? If it was less than 90 and also greater than or equal to 70, that's a C. That's the range I was asking about. Yeah? And then otherwise, if it wasn't this, you know it's strictly smaller than 90. If it wasn't this, you know that it's also strictly smaller than 70. So if you ever get here, this was false. It was 69.999999 or smaller. So it's strictly smaller than 70. You didn't even have to check for it because the else case took care of that. Okay? Any questions on why this is the proper order, why this works? The job of this was supposed to convert the grade to A, C, or F. We can do a fancier grade calculator next time, but I think you can see how you might expand this to include B's and D's, right? Okay, are we good to move on to our last topic of the day? Okay, so let's talk about bools. There's a type in C++ called bool. It's perfect just in time for Halloween. And it stands for Boolean. It is a type that all it can hold is true and false. That's pretty nice. So yeah, bool is a type. Its only values are true and false. Whereas for ints, there are like billions of options for an int up to its range. Negative 42, positive 42, 0, all the stuff in between. It's fine. It all works out. The bool cloud is a very small cloud. All it holds, all the values of the types are true and false. That's all you get. It can only be one or the other. All right? And you can assign into a bool variable any Boolean valued expression because it's going to become true or false, right? Anything that you would put in an if statement's condition, you can put into a bool variable because it's going to become true or false. Like you could ask bool b, make a variable called b that is a bool, and set it equal to, hey, is 42 less than 43? Because this will be true, right? It'll put true into b. Does that make sense? So you got your box that is b. Oops. Got your box that is b, and it holds true after this. Okay? That's the idea. True. And then you could condition off of a Boolean variable. You could say if b. It'll just take whatever the value is inside of it. If it's true, it'll run its body. If it's false, it won't. Does that make any sense at all? It's just a variable that can hold true or false. And whenever you use a variable, it gets replaced with its value. So saying if b is the same as saying if b is equal to true. Just replace it with its value. Any questions about that? I'll show you a program with bool variables explicitly right now. But that is the idea, at least. Yeah. Okay. Let me show you bools. So yeah, you can say bool b1 is equal to, I don't know, 42 less than 43. So that'll become true, right? You can say bool b2 is 45 greater than or equal to 55. And you can also hard code it. It's like bool b3 equal to true is lowercase true. False also works. Before hard code it to false. Okay? This will eventually be true. This will evaluate to true. This will evaluate to false as well. But you have the values as well. They're lowercase. Which is different from Python if you've learned Python. Those are capitals. Yeah, so you can see out them. See out b1, see out b2. And it prints them as numbers unless you do a weird formatting thing to see out, kind of like the fixed and set precision. There's a way to change it to print bools to not be numbers. But by default, they are, and 1 means true, 0 means false. Okay? That's that. And you can also condition based off of them. You could be like, if b1, see out, well, b1 was true. The only way we hit the body is if b1 was true, right? It evaluated to true. It held true. And that will print. You can say if b2, see out b2 is true. And b2 is totally false, so let's have an else case for that. See out b2 is false. Alright, so it'll print like that. It'll print b1 was true, b2 was false. It just gets replaced. What was b2? Well, it was the result of this, which was false. So this becomes if false. That's definitely going straight to the else case. The body of the else. Trying to use those new terms for us. But yeah, I think that's the start of what I wanted to show you. Any questions about this program so far? Because the last thing I want to show you for the day is something we'll talk a lot more about next time. It will be ways of combining Booleans together. Because right now we can really only ask one thing. We'd like to be able to ask multiple things at once. So there's a way to combine conditions with combining Booleans. And one of the operators is 2 ampersands. This is called AND, which makes sense because it's an ampersand. So this means and that will make both of these two pieces of code equivalent with this extra power. So before, if I didn't tell you that this existed, you could get the equivalent of checking for evenness and positiveness by having an if inside of an if. Like, if it's true, if it's even, then we're in the body of the outer if. If it's also positive, we put another if statement checking for positivity. And if we're inside of both of those, then we know if we got here that we were even and positive, right? That's nice. But also kind of clunky. So there's a way, if you just want to check for evenness and positivity at the same time, you can combine those two Boolean conditions. You can take your check for evenness. You can take your check for positivity and ask, are they both true? You can combine with the and, okay? Hey, is num even and is num also positive? Okay? And so that makes it a bit cleaner. You can use the ampersand for that, okay? And so that'll be true if they're both true, okay? Which is the English definition of the word and, I think. That should make sense. I do want to get you used to these little tables, though, even though and is kind of obvious. This is called a truth table. So here is B1 and B2 for every different possibility of B1 and B2. That's what a truth table is. It shows you exactly the result of this little combined thing, combining operator. So, yeah, B1 and B2 is true, and both B1 is true and B2 is true. So the only time you can think of B1 as, hey, is it positive, and hey, B2 is, hey, is it even? You can think of it being positive and even. There's only one case for that, right? If B1's true and B2's true, the result of their anding together, with them being anded together, is true. Any other case, it's false. Hey, is it positive and even when it's not even? No, of course not. It's false. Hey, is it positive and even when it's not positive? No. The combined result is false. Hey, is it positive and even when neither of those are true? When it's neither positive nor even? Of course not. So it's only positive and even when they're both true, right? When it is positive and when it's also even. Okay, so that's a truth table. That's the result you'll get. Okay, does that make sense? That's the one row where it gives you true back. So let me just show you that in code before it's lab time. So see out true anded with true. What was the next one? True anded with false. False. I'm sorry. False. Yeah, false anded with true. And then false anded with false. So it's only this case that is the true case, right? One, zero, zero, zero. Okay? So that's the and operator. It combines things. It's only true if they're both true, though. Any last questions on that one? There are other kinds of combinators for Booleans. There is the OR operator, which I'll show you next time. Like, it's true if one's true or the other's true. That's another kind of question that we'd like to ask about two separate ideas. Hey, is one true or the other true? Is it positive or is it even? Do something, no matter which one, as long as one of them's true. Something like that. So that's and then we'll do or next time. There's also one more. Okay? But that, I think, is where I want to stop us for this lecture. And let me release your next lab, and then you can go off and work on it. So, got a lab due this week, so I'll assign another one now. This one will be due next Friday. So the 26th. This is lab 1, because it started at 0, of course. I'll delete that, because this is the introduction video. I had to do it a little bit separately last time. But all we need is the write-up. The introduction video is part of the lecture right now. Boop. So here is your lab 1. Here's what you'll be doing. You'll be getting the average of some random numbers. Then you'll also be calculating the sales tax for an interesting universe. Okay? So this is just practicing using library functions right now. I don't think... Am I asking you to... I think you can get away with not having to use any if statements in this lab, actually. So you're welcome. That'll be the next one then. So let's get the starter code for this one. Let me connect to the class server. As usual, you'll use the gimme command. So you'll say gimme lab01 at CSCI40, hit enter, and it'll make a new directory called lab01 wherever you were. Go inside of that. And then here are your files. You got randomaverage.cpp and salestax.cpp. So the easier one is the average one. Get the average of 5 random numbers, and here's what the program should do. Here's what it will look like when you run it. You will say, I gotta fix this link again. That's silly that when I make the PDF on the Mac, it doesn't let the links stay. But if I make it on a PC, it keeps the links, and they're clickable. I will fix that, don't worry. You can also just search for C++ cstdlib like I was doing last time. So this first program, what you're going to do is you're going to generate 5 random numbers, and it better be different every time you run the program. Generate 5 of them. And you're going to calculate the average of those random numbers. Each of them is going to be between 1 and 100. Okay? Those are your random numbers. Can't be 0 and 100, it's 1 and 100. Okay? Then you'll print them out, and you'll output their average rounded to 2 decimal places. Okay? Always 2 decimal places. So you're going to have to control with set precision and fixed and all that stuff. Okay? You'll have to use rand in a special way to shrink down the numbers as we were doing last time. So yeah, here's kind of what it should look like. You'll make your, you'll print exactly stuff that looks like this. Print random numbers between 1 and 100, colon, new line, your 5 random integers that you calculated between 1 and 100, and then you'll print the average of them rounded to 2 decimal places. So no longer are you doing integer division on this lab. You are doing actual floating point division. You'll have to maybe do some conversion. Okay, so that's how it should look. And did I say anything useful in the starter file? Look at me, I was so nice to you. I even seeded the random number generator for you. So get your 5 random numbers, do that, print them out, 5 separate lines, and then print their average. Okay, it should be pretty self-explanatory. Okay, so that's random average.cpp. That's the easier of the two, I think. And then here is the next part, the last program you're going to work on. You're going to write a sales tax calculator. So the user's going to enter a price, and you're going to generate the sales tax for that, and then print it out all pretty. Okay? So for this program, you'll get an input price from the user, and you will calculate. We'll pretend that the sales tax in Fresno is 7.75%. I think it's a little bit more now. Maybe it used to be this. I can't remember. You're going to calculate that sales tax for the price, and you're going to round it to the nearest dime. You're not going to round it to the nearest whole number. You're going to round it to the nearest dime. We're going to pretend that pennies and nickels do not exist in this universe. Okay? So you'll have to think about that. How do you round a number to the nearest tenth rather than the nearest whole number? There's ways to do it with cout. There's ways to do it using the round function, which does round to the nearest whole number. You have to manipulate the number itself before you give it to round. There will be a trick involved. So look at the docs for round. That's in CMath. I've also given you a hint down here at the end of the file. So read that if you're stuck on how to round to the nearest tenth. That should help you. Okay? But yeah, you're going to calculate the sales tax rounded to the nearest dime. So if the user enters 1220, what's 7.75% of that is you multiply it by 0.0775, right? That's how you get percentages. And so that's supposed to be 94-ish, 95-ish cents, but we're rounding this to the nearest dime. So we're going to round, I think we're going to round down to 90, right? Yeah. So this becomes 90 cents. Going to round it down to the nearest tenth, okay? Because it's smaller than 95. All right, other example. So if the user types 4730, 7.75% exactly is $3.66-ish, but we're rounding to the nearest dime, so we round up to $3.70. That is the sales tax in a world without pennies or nickels. Does that make sense, what I'm asking you to do? That kind of rounding? All right, and then the rest of that is just make it look pretty. The user is always going to enter in a price, at least in my test. The user will always enter a price that also does not have any pennies or nickels in it. And then you'll calculate the sales tax based on that. Add them together, make it look all nice. Okay, so that's how the formatting should look. And here is my sample code for you. So I've already let you get the price. And then we do calculate the tax, round it to the nearest dime, and then print all this. Print the price, print the rounded sales tax with a plus in front. The line with 10 equal signs got to look pretty and exactly like this. You got some spaces at the front, so 2 spaces for the first line, for example, a plus and a space, and then the next price. You got to put a dollar sign as well. Make it look pretty. Just follow the write-up, and that should do it. Okay. But the trick is figuring out how to round to the nearest dime. Right. Again, see this hint at the end if you're having trouble, or just talk to me. And so those 2 files you will be editing and turning in, and that will be your lab. Any questions about either of them? So random average, generate 5 random numbers, get their average, print it in a special way. Sales tax, get a price, calculate the sales tax, round it properly, make it pretty in the output. All right. I think we're good then, so I'll stop recording.